This is Note-Taking Guide 4.3 for Math 3. Today we're talking about cube root functions and their graphs. So we've been talking about inverses this chapter or unit, and so we're going to start again by looking at the inverse of an x cubed function. So to find the inverse, we know that our f of x is represented by a y, so we're going to interchange the y and the x values and then resolve for y. So to get rid of the cubed on the y, I'm going to cube root both sides. So over here I get the cubed root of x, and over here I get just y. I have to change that y back to my function, which was f of x, and I did the inverse function of it, so I'm going to throw that -1 on there to symbolize the inverse. But the point being here is that when we look for the inverse of x cubed, it's going to be the cubed root graph. So just a quick reminder what that x cubed graph looked like when we graphed it. It looked like this. So the inverse of it will be the reflection of that graph over the line y equals x. And I'm going to show you what that is in just a second. So again, doing the algebra to find the inverse function of another cubic graph, we know we're going to end up with a cube root somewhere because that's the inverse of a cubed graph. So again, our f of x value represents a y. So we're going to take that y and replace it with an x and do the x replaced by a y and then resolve it for y, just like we have been the last few days of notes. So in order to get the y by itself, the very first thing I need to do is move the 5 over to the other side. So I'll have x minus 5 on this side. And then over here I still have y minus 2 in parentheses cubed. In order to be able to bring that y out of the parentheses, I have to get rid of that cubed, and I just told you that the inverse function of cubing something would be to cube root it. So I'm going to cube root both sides to get rid of that power. So over here I'm simply going to rewrite it as a cubed root. It doesn't get to go, a lot of kids are asking me if they can multiply that out or something, but no, we're just going to leave it written as the cube root of x minus 5. And then over here, the cubed and the cube root cancel each other out to just be y minus 2. So one last step to get y by itself would be to get rid of that 2. We're going to add the 2 over. The 2 is not underneath a radical, so it can't really combine with any of that stuff. We're just going to throw it back behind and leave it alone. I need to set that back equal to y, but right here I'm going to change it back to my inverse function of f of x so that I don't have to rewrite it one more time. So our inverse function of this x cubed graph is this cube root graph. All right, let's go on and see if we can graph these. So the other day when we graphed the square root functions, we had domain restrictions. So we're going to fill out a table here of values to see whether or not the cubed root graph has domain restrictions. So our original cube root graph is f of x equals the cube root of x, and we're going to just substitute some values in. So use your calculator to see when you substitute -8 in whether or not you get that same domain error on your calculator or whether or not it will give you an answer. So cubed root of x, substitute -8 in for x, so we'll have the cube root of -8. If you do that on your calculator gives you -2. I know some of you probably thought that that was going to be undefined because it was a negative underneath a radical. But the negatives only really matter underneath the radical on the even roots like 2 and 4 and some of the other ones. This odd power makes it okay because can I times -2 by -2 by -2 to get a -8. So it actually follows that cubed pattern okay with the negatives. So it doesn't really look like we're going to have domain restrictions here, but let's keep trying and see. All right, if you do the cube root of -6, you're going to get a decimal point number equivalent for that. If you do the cube root of -2, it's still going to give you a decimal point number. Cube root of -1, I do know that one without my calculator. That's going to be -1. The cube root of 0 is going to be 0. The cube root of 1 is 1. And then if I skipped over here to the cube root of 8, that will be 2 again. This will just be the cubed root of 2, and this will be the cubed root of 6, unless you want to get those decimal point numbers. But I really have enough numbers there to graph my graph and see where I'm going there. So my first ordered pair would be negative 8, 2. So I'm just finding that ordered pair and I'm graphing it. And then I'd have the ordered pair, if I just skipped to the nice ones that I did, I had negative 1, 1. Oh, negative 1, negative 1. I didn't read my writing right. I have 0, 0. I have 1, 1. And I have 8, 2. Now, just a second ago, I told you that the cubed graph that we used to draw looked like this. And you can see what the cubed root graph is going to look like. It's going to look like this. So your graph's going to be like kind of a S on its side kind of thing, just a squished kind of S. So hopefully from here we should be able to just use our patterns and be able to do some graphing without having to do the table of values. Oh, I forgot to look at the domain and range on this last one, so let's take a look at it really fast. If we're looking at the graph here, what's the domain? How far left does it go and how far right does it go? Well, it goes forever to the left and it goes forever to the right. How low does it go? Well, it's going to continue to go down and it's going to continue to go up. So this time we do not have domain restrictions on our graph. So we don't have to worry about parts of it being missing. All right, this next one right here, let's see if we can do this without a table of values and see if we can just graph it by looking at the movements. That +1 right there follows the same pattern that every other graph that we've drawn has followed. The plus inside attached to the X moves us left or right. Because it's plus, it actually moves us left. So we're moving left 1 unit. And then that -2 right there, because it's outside, moves us up or down. Because it's negative, it moves us down 2. So I go left 1 and down 2 for my starting point on my graph. Now I want to go back over to this other graph for just a minute because we're just going to sketch these really rough like, but I want to bring a point to you here. To get from one point to the other, so this middle point right here, we went over 1, up 1. And we went over 1, down 1. So we're going to just do that same pattern to get a real good sketch of what we're doing here, and then we're going to just sketch our graph. So we're going to check to see if there was a pattern change first of all, and there's not a number out in front right there. So I know I can go over 1, up 1, and then over 1, down 1 the other direction, and just draw my S-shaped graph through there. We're just going to sketch these kind of rough like today to see if we can follow the patterns. Domain and range are still going to be negative infinity to infinity, and the interesting thing about this graph is that the domain and range can never change on this. We can't change it to not do that same thing. We can enter any value we want in for X and get out a value for Y. So the domain and range on the cube root function will always be negative infinity to infinity. Okay, so just a reminder then, what we're doing here is we're graphing the reflection of the original graph over the line y equals x. So the original graph is right here, and when we reflected it over that yellow line that I just drew, we get that graph that I've been drawing. We get this one right here. So this is the graph that we're drawing, that reflection. Okay, let's keep going. So here's the transformation part again. We're just going to run through this really fast. We're starting with that original cube root graph. And this +3 right here outside, it looks like it wants us to take our y values and add 3 to them. So it is exactly that. This is a transformation up 3 units. So we're going to take our graph, our original graph, we're going to move it up 3 units, and we're going to follow our pattern. Our pattern was to go over 1, up 1, and over 1, down 1, and draw our S-shaped graph through those spots. When we're looking at what kind of transformation that was, because we moved our graph up, that is a vertical transformation. All right, next one. When we're looking at our original graph again, it says to go +2 on the x. Now again, if you remember what I said last time, that +2 was either left or right, but we always have to think about it as the opposite because we're really trying to find the value that makes that 0. The value that makes that 0 is -2, which means we're moving to the left 2. So when we graph that, we don't start at 0, 0. We actually move left 2 and draw our point. Because there was no pattern change on that, we're going to go over 1, up 1, and over 1, down 1, and draw our graph through those ordered pairs. You'll notice again, we still go all the way to the left, all the way to the right, all the way bottom, all the way top. So domain and range doesn't change here. But what type of transformation was this? Because we moved left, this is horizontal. Okay, this last one right here asked me to take my y values and multiply them by 2. So we didn't actually move left or right or up or down, which means we're going to start at 0, 0. So we're starting right here. Then we're going to follow our pattern. Our pattern normally is up 1 over 1 and down 1 over 1, but I was asked to multiply my values by 2, my y values by 2. So normally if I go up 1, I'm going to multiply that 1 by 2, and I'm going to go up 2. So I'm going to go up 2 over 1, and I'm going to go down 2 over 1 to draw my new graph. Because this affected my y values, it is a vertical transformation. All right, let's see if we can take everything we've learned so far and just graph these. Just a reminder again up here that the number inside and the number outside tells us our vertex point, where to start. And the number out front tells us what to multiply our y values by. Our domain is always going to be -infinity to infinity. So here we go. This -1 right here asks me to go right 1, because inside the grouping symbol it's always the opposite direction. This -2 right here asks me to go down 2. So I'm right 1 and down 2 on my graph. Right 1, down 2, that's my starting point. Do I have a pattern change? No, because there's not a number out in front there. So I'm just going to go up 1 and over 1, down 1 and over 1, and draw my S-shaped graph through those ordered pairs. Domain and range is going to be the same thing it's always been, -infinity to infinity, and again, -infinity to infinity. All right, let's see if we got this one more time. Last problem here. The +4 asks us to move left 4. The -1 asks us to move down 1. And the 2 out front says multiply your y's by 2. So I'm going left 4, down 1 to start my graph. Normally I would go up 1 and over 1, but because I have to multiply my ups by 2, I'm going to go up 2 and over 1, and I'm going to go down 2 and over 1, and my graph's going to come through those ordered pairs just like that. Domain and range, same thing, still forever to infinity to the left, forever to infinity to the right. Range is going to be doing the same thing, increasing and decreasing forever. That is how we graph a cube root function. Good job, and thank you for watching.